Sounds great.
All right, go ahead.
All right. Hi, my name's Ian Huff. I'm a developer here for Visual Studios and the Enterprise Developer Tools team. Our team's kind of got two parts to it. We've got a static analysis team, and they make tools that kind of run over your code and look for issues like buffer overruns and those type of things. And then we have the team that I'm on, which is the dynamic analysis team. We're working on a profiler, and what that does is it runs over your code as it's running, and it helps you find and isolate performance issues that are in it.
Cool.
So I am going to jump in and start showing what we have here.
Cool. And all this stuff you'll be able to play with in beta 2?
Absolutely. Visual Studio's team system. It will be there. So I went to a got.net to get a sample program to use, and I actually just pulled one off this morning. It's a rational numbers program that takes rational numbers and it factors them down to their lowest level, and I'm just using it as a good tool for this performance tools. So I have the solution open right here. I got the code out right now. I'm going to start out by going to Tools, Performance Tools, Performance Wizard. Now, some people don't like wizards, think they're a little cheesy, but this one's fast and easy, so I'll go through it quick. You want to pick what target you're going to profile here. You could choose to profile an executable, a DLL, an ASP.NET web application, and it'll also list all the different projects that are part of this solution. And the only project in here is the rational project, so I'm going to pick that guy and move on to the next selection. Now, a big part of our profiler, and one of the really nice features of it, is that we have two different modes of profiling, sampling and instrumentation. And it's really important also to know the difference between these when we're going over this. Mm-hmm. So a sampling mode, every X number of events could be clock cycles, they could be page faults, they can be other performance events, it'll stop and it will report its location, it'll tell you what the call stack is, and it'll report that data back to you. Now, the pro of sampling is that with sampling, you have very low overhead. It doesn't perturb your program as it's running much. Mm-hmm. The bad part is you don't get like hard data. You don't know exactly how many times a function is called because you're only sampling every so often. So it's good to start out with sampling mode usually. It'll give you an overview and you can pick out like hotspots in your code where you want to focus in later. And when you want to focus in, you want to use instrumentation mode. Mm-hmm. Instrumentation mode actually injects code into your executables and DLLs, and that'll give you every function entry and exit. So it'll give you really hard data. So I'll start out with sampling mode. I'll click next, and then finish the wizard. And our Performance Explorer will be up over here. It looks like a Solution Explorer. It's kind of just the launching point for all your performance sessions.
Is that written in managed code, native
code?
Yeah,
this is actually a managed package. Some of the analysis of our stuff is native code, but the layer on the IDE is all managed code.
Cool.
It's managed C++ actually, which is kind of new to me. I'd usually used C# before, but it worked very well for this. Anyways, you can see the different sessions we have right here. It's called Rational 1. You can see the executable here is listed under targets. That means we want to be profiling it, and it's set with the green arrow to be launched when we run it. So we'll go ahead and get some data. I'll hit the launch button. Here's our process. I'll hit the performance button, which runs the scenario that I want to profile. It just creates some rational numbers and then gets rid of them. I will now exit because it's run my program. The file is exited, we create a VSP file. These are our profiling session files, like they correspond to each run of the profiler. And automatically it'll start loading it up after I've run the session. So here we go. We have now loaded up our VSP file. Our VSP file is here. We have a bunch of different analysis views that I'm going to walk through kind of as we diagnose and look for a performance problem. The first page is the summary view. We've got two different things here. We've got top inclusive sampled functions and top exclusive sampled functions. So the difference is pretty important. Inclusive means the sample was in this function or one of its children, and exclusive means it was just in this function. So usually your top inclusive one is like your main function because everything else is below that. Mm-hmm. A little better way of finding the actual issues is usually looking at exclusive. And if we look at that, we see there's a function called rational.reduce, where almost 78% of the function samples are taken in. So we see that guy right here, 686 of our samples. So if we click on that guy, it'll jump us over to our next view. This is the function view. Instead of just the top one, this shows all the functions that we got samples in. It'll tell you what % of the samples were in them, both inclusive and exclusive, and it will tell you the ultimate number of samples. We have a lot more columns, but these are kind of just the basic ones you need to figure out a performance problem. So as we can see, our real issue is this rational reduce guy. So if we singled him out, a good thing to do now would be to jump into instrumentation mode, because now we know where our issue is. So I'll close this file. Now, right here is the little scenario that I'm running where we create 5 different rational numbers and then factor them down. I'm going to get rid of a few of those and comment them out because instrumentation collects a lot more data. You don't want to start with that or else you get a really big VSP file that'll take longer than we want to do to analyze. So I've made that guy a little smaller, rebuild my solution. And now what I could do here is I could change this session to be an instrumentation session, but I don't want to do that. I like to keep mine separate so I can kind of remember where I am at with each of these things. So I create a new performance session. It shows up here. Now I want to set that guy to instrumentation. Up at the top we have a little menu bar for that. You can also do it through the properties page for them. And then we go add target project. It knows that there's only one project, so it just automatically adds this guy. It looks about the same as we've got below it. However, it's got little 1s and 0s in the binary. This indicates that that binary is going to be instrumented. If, for example, we had a really big project with like, dozens of DLLs and XEs, you can choose which ones to instrument and you'll only collect data from them. So it's important to know that. When I look at the performance of our own tools, I just instrument our DLL and then run devenv as just not instrumented. So we'll hit run and we'll do the same scenario as last time. Hit performance. It runs it. We'll exit. And here goes our profiler report in the same spot over there. It actually has quite a bit more data than the sampling one just because of so many function calls. Here's our summary view again. It's a little different than the sampling summary view. We can see which functions take the longest. What that does is we get entry and exits, and we have a timestamp for each of those. So it's just a simple subtract one from the other and figure out how much time they're taking. And then the other two are also a little more interesting. We have most called functions. That tells us who's called the most. As we see, we've got this guy, get upper bound, who is called a lot of times. Almost 90% of the total calls are this guy. And then we have functions with the most individual work. Those are the ones where we actually look at the work done just in that function. And our culprit is, again, that rational.reduce function. Takes 140 nanoseconds that we're dealing with. So we want to look at that guy. We'll move to function list again. It looks about the same as function list with samples. There's a few different columns here, but we still just can see there's the number of calls to it, the exclusive transitions, and the inclusive transitions. If you want to get a better sense of where this function is in the program, you can use 2 different views. One of the views is caller callee view. If we right-click on the function, we can choose the option show in caller callee view, and that moves us to this view right here. Here's our current function right here. This lists all the functions that it calls and how many times they're called. And this lists the functions that calls it and how many times they called it. You could browse up here, like up to your top level forms. So right here we're at system application run. And then we can see perf button is clicked. We can see many times function is called. That calls the rational constructor, which calls reduce. So here's our guy, and we see that reduce is the one who's calling that get upper bound all the time. So that's interesting. Also, we have the call tree view, if you prefer to visualize things that way. It starts out just with a hierarchy view, starting out with your top level node, and then you can investigate down to find your function of interest. Just like we did last time, there's reduce in our is small prime. Now at this point, we've already seen that we think reduce is the problem. So if we go to function view, we can right click reduce and then go view source. And as long as we're in that solution, we're popped right to our source file now. Now, when I downloaded this today, I kind of thought that I would have to seed it with a performance issue to make sure we were finding something. However, like most programs, it came with its own built-in performance issue. When I was looking through it, I saw that get upper bounds was right here. And that was the one that was being called so many times. They were calling it as a check on a for loop. So every time the for loop ran through, this function was being called. So for the quick fix on this guy, I'll put this little integer here with that value in it because the value is not changing. And then I will say here. All right, and we'll save that guy. Close down the VSP file, and we will rebuild that solution. And remember last time it took about 140 nanoseconds for that one, and that was called about 85,000 times that upper function was called. So now we've rebuilt it. We're going to run the same session we did last time. Launch the session, run performance, and then stop. We exit from the data, our analysis loads. Now this time, if we look at our functions, it only took 73 nanoseconds. So we've cut our time spent in that function about in half. And that number, that most called function is no longer there. It's only called about 5,000 times, which is all it needs to be called. So using our tools, even a fairly new developer like me was able to pull down a random project that I've never worked with before from the internet, find a performance problem, and speed up the program about 25%. And
how often do you do that? As in terms of the way you test these new tools? Like just say, hey, we need another program. Let's find one. Let's sample code.
Yeah,
Post it out there. Let's find performance bugs.
A lot of times the testers develop some really good programs for us to use. We run it on our own stuff, which is good. You got to be able to use your own programs.
Yeah.
And then there also is, like I got this one, got.net. You can run out there, and there's a lot of small managed sample type apps that you can usually find lying around and run it on. And it's good to be able to use it like this. This situation was a little small, you know, but it's really handy for bigger things because you don't want to be able to have to search through someone else's source code trying to find performance problems. I want to show another quick thing. Cool. When it's a .NET program, you can also collect object information, which is a very key point of our profiler and a very neat thing. We'll go to the properties of the session here.
And all this stuff works on non-managed code as well.
Yep, it all works on native except for what I'm about to show now, because you've got to be in .NET for this.
Yeah.
So when you're in instrumentation mode, you can say collect .NET object allocation information. And when you collect that, you can also collect lifetime information. So I'll set those to OK. And I will run our same little demo here. It runs it. I'll exit. Now when this analysis report loads up, we'll have a couple different options. We'll have allocation and object lifetime down here.
Okay.
The first one, allocation, it shows all the different types that were allocated at any point. In that, we also see the number of instances that were allocated, the total bytes that were allocated, and what % of the total bytes that was. So if we sort by this column right here, we can see most of the bytes that were allocated by system byte array. And when you open that up, you can see where they all came from. And there's your system string. You can see exactly who's allocating what. And in addition, in any managed program, there's garbage collection. So instead of you deciding when to free up the memory, the computer's going to decide when to free it up.
Yep.
And lifetime is very important for tracking this type of thing. It has the same view of all the different class types. It tells you the instances and total bytes again. However, this also tells you how long the objects persisted. Generation 0 garbage collections happen really often. Generation 1's a little less often, and Generation 2's pretty infrequently. And what this tells you is how many instances of each object lasted to, say, Generation 1 or Generation 2. Now, in this program here, nothing lasted that long because it was so short. But this is really important for big applications because if you're holding on to large objects, you're going to be eating up your memory and have to garbage collect more often. So object and allocation ones are a really nice new feature of our guy. And that is our little overview of the performance tool.
Cool.